Hi, welcome to product review by watthour. In this video we are going to do the review of this Drok 800 watt boost converter with the input of 10 to 65 volts and output of 12 to 120 volts. We're going to do some tests of this, but my test failed. I purchased one, I went over the limit, I went up to 900 watts or so. So this died, and I purchased another one waiting 1 month or so, and this one arrived. Now this one died without I did anything wrong. So my test was done half on this one for the review, and then when this died I could not complete it, but then I repaired it by getting some components from here, putting it in here. It worked, but it did not work properly. I don't know, it was the damage before the repair or after the repair, which I broke a piece. Anyway, so I did not want to throw this recording out. Maybe it will benefit some people. So I'm posting this because I did not want to edit and waste my time, because the video was not with the level of my expectation. Please do not complain that it was not organized. My method is not to post a junk video, so this is just above junk. And I will show you a lot of tests. Maybe it will be useful for many people. If this have worked, this would have been amazing product, but it did not work. So I'm posting it, and you can watch it at your own discretion if you like it. If not, don't worry. I know this is not a good video, but I'm posting it because I thought it would be waste if I throw it. So I give you the warning from the beginning. Just watch and maybe you find something useful. Please forgive me for the quality of audio, because 120 volts. For some reason my monitor was on and there was some audio feedback and it created huge echo. So bear with me, or maybe just close this video. Do not watch it. Please do not complain. If for some reason you think it's useful and you want to buy it, I will provide you the affiliated link below this video so I can get some commission from that. It will help me, and make sure to purchase it via that link. Now let's have a look at this Drok 12 volts to 120 volts 12 ampere boost converter. This is the module with LCD display. This is a detailed video. You may use chapters in this presentation. First I'm going to explain this Drok boost converter, then we will look at the components under the magnifier. The settings will be explained. After that I will check the input output voltage, and then see the input output current and voltage accuracy. I'm going to also test a lithium iron phosphate 4-cell batteries to check the test to charge the battery. And also we are going to have a look at the switching frequency and output ripple voltage in different stages of tests. And then we are going to test MPPT, which is used for solar charging and input output control. The main feature of this one is that Vout must be equal or greater than Vin, and output must be greater than input, because this is a boost converter. And maximum output power is 800 watts, and effective power is input voltage times 10. So if you look at this, then it will be 650, because the maximum voltage is 65. They have given in the manual the example of if Vn is 12 volts, then effective power is 12 times 10, 120 watt. If the input voltage is 24 volts, the output is 240 watts. And if input voltage is 40 volts, then we get 400 watts. Now, if this is 65 times 10, 650. There is no 800 watts based on this documentation. It has constant voltage, which will keep the output voltage constant, and it has constant current, which keep the output voltage which keeps the output current constant, and it has LCD display. Input voltage is 10 volts to 65 volts, Very important to pay attention to this. And then the output is 12 volts to 120 volts. You can set minimum voltage of 100 millivolts or 0.1 volt. For that reason, this is not suitable for lithium iron phosphate battery, because we need to be able to set about 30 or 35 millivolts. This is 100 millivolts. So I will suggest not using it for that purpose. Output current is 0.1 to 12 ampere you can set, and maximum current is 12 ampere. And output ripple is 150 millivolts typical, which we are going to have a look at under the microscope, which we will look under, which we will connect it to oscilloscope and check it, which we will connect to oscilloscope and check it. Operating temperatures from minus 10 to 40 degrees Celsius. This is not trustworthy if that is 40, because in many areas on Earth the normal temperature is 40 degrees Celsius. So let's see. And it has the following feature. Something is called automatic output tuning. Automatic output, so you can set the output to be turned on or off when you turn it on. Then we have a cooling fan, which will be turned on at 1.5 ampere or 40 watts, whichever is greater. And the fan is consuming 100 milliampere at 12 volts. It operates with 12 volts. It displays also input voltage, which is very important. And it has the following protections: input low voltage protection, LVP. We have output over voltage protection, OVP. These are the values that you set, and later on, if you make mistake and set the value below this, it will be turned off. Turn off the output, and if you set it above this value, the output will be turned off, so you cannot make mistake. And then output over current protection, also you can set the current, for example 10 ampere, and if you try to set it higher than 10, it will turn it off. And then it has something called self-tuning regulator. So when you set low voltage protection, it will turn off the output, but if the solar voltage, solar panel, let's say, increases, it automatically controls and sets the input voltage, so the output can be achieved if the voltage goes high. And MPPT for solar panel uses all these features: low voltage protection over current, over voltage, and self-tuning regulator, so it can work. So all of these settings will affect it. For example, low voltage protection, if you set it below this value, your solar panel voltage, if it goes below this, the output will be off. And if the current goes higher, the charging from solar panel will be turned off. And also power, if you set it, will be turned off. And also self-tuning regulator can be also controlled, and it will affect the MPPT when you turn it on. The test that we are going to do is with the input maximum 65, and then the outputs all these voltages from 70 to 120, and then we change it to 50, and we check all these values, and then we change it to 36 volts, and we test the output with all these voltages with different current, and then we change the input to 24 volts, and we start from 36 to 120. Then we change the input voltage to 18 volts, and we check all these output voltages. Then we change it to 12 volts and check all these voltages. Because the minimum is 10 volts, we always set it to 10 volts and check all these voltages with different currents. Please don't forget to subscribe by clicking on the icon on the lower corner of the screen. I really appreciate it. Thank you. This is the package that I received. I just opened it. And that's nice. We got a color manual like this. Let's open the package. So this is the module. seems very solid, and seems somebody cared to put extra solder, even though not much, but they put some on the module. The standoffs are already installed. Hello. So it's keeping it up from ground. The fan is also installed securely. The display, everything looks solid. Very nice, very nicely wounded, very nicely built inductor. So we have in here we have an input, and then we have an output. On this side we have a 15 ampere fuse. We have a rotary encoder, that's nice. We have these 5 switches, so they seem to be nice. We have 2 large resistors here, 1 resistor, and this is an inductor, I believe. (12 volts, 100 milliampere fan). So if you pay attention to the input it says 100 volts, and here the output is here the input capacitors have rated voltage. Here the input capacitors have rated voltage of 100 volts, and the output after boosting we can get higher voltage, but here it says 250 volts. Now let me explain the settings. We have these 4 buttons. This is labeled as set, left and right, 2 arrows, and then we have MER and then output. The star shows that which item is selected, so we have 2 lines. This is LCD 1602, 16 characters and 2 lines. The quality of the color is gray. It's interesting, very beautiful. I've not seen it sold, this item. I've not seen this item for sale, this display, but this is very interesting. So to set the output voltage, to set the output voltage, you press set, and this moves from one into the other one and disappears. Now when I press set, there is underline under the 7. I can rotate this rotary encoder to set the output voltage. On the screen we see the input voltage here, so we know that we should not go below this, and it will not work, and the output will be turned off if the output is lower than the input. I'm just reducing it to now. I've reduced it to 22 volts or 23 volts. Now to set the voltage, when you see the underline under any digit, you can just rotate it and change the output. So this is the output. If I want to go to the next digit, just move the underline and you can change the 8, and it becomes like that. And if you want to go to the 100 millivolts, the resolution is, by the way, very low. This is not suitable for lithium iron or lithium ion or lithium iron phosphate batteries, because we need to have control of 10 millivolts. This is 100 millivolts minimum, so now it means 69 volts and 900 millivolts. So from here you can set that, and if you want to change the current, just press set. The asterisk or the star moves to the next line, and then we can change the current from here. When you rotate it, because the maximum is 12 volts, you will set it to 12 volts. It does not mean that you can get 12 volts here. because the output and input voltage will affect the output current, which we are going to test it. But the manufacturer says the current will be from 0 to 12 volts, and then they mentioned that it is not possible to get all these voltages because in some voltage and current you will go above 800 or above 12 ampere, so that's not possible. And now this is the current, and once you're done with this, just press out, and now this is the output voltage. It says CV. This is the output voltage, and this is the input. We can see also the current and power. I've not connected any load, but if you see MER or meter, if you press it, now it will change to ampere hour if you're measuring the capacity of a battery or you're paying attention to the time. So this can be switched on or switched off. You can press it and come back. So this was the main basic settings. Now we have further settings. One of the important features of this one is automatic power on when you turn it on. So you can set it when the power goes off and on. It can output automatically or not. Now if I press the set, so press out again, we are exited. Now you see the star. If I press it again, it comes here. If I press it third time, it disappears. At this stage, we can rotate this rotary encoder. And here this says low voltage protection. Low voltage protection is the input voltage that this is a voltage that if the voltage goes beyond this value at the input, it will turn off the output. Let me show you. Now you can see we can press this out to turn it on and off. Now if you want to change any of these, just press set and you will see the underline appears. Let's move it and set the output voltage to 30 volts. Now we are at 30 volts and output is now on, and let's press set. How can I exit? And when this is done, press MER and it says saved SD or whatever it means. You will see that this appears here. And to exit, we just rotate it when nothing is selected counterclockwise. And now output voltage is set to 30 volts. Now the low voltage protection is set at 30 volts. Now input is 23, output is 70. If I turn this off and on, the set cannot work because the output is off. Now let me change the input voltage and let's go above 30. Now I set it to 32 volts. Now if I turn this on, you see the output works. So the low voltage protection is for the input to protect your battery or solar, whatever system you have. You can set it. Let me go and turn it off. So rotate. Now go back, press this until you don't see the star, and then rotate low voltage protection. From here, just turn it off. Now let's go to the next feature. I'm just rotating this, and this is called STR. This is called self-tuning regulator. When the low voltage protection protects the device and it keeps it off, if the input voltage goes high, if you set this to a self-tuning regulator, then it will turn on the output. Very easy. The same way, you can just press this on and off and then press set to set your voltage at whatever voltage you say. If the voltage reaches at that value, turn on the output and ignore the low voltage protection. Now let's have a look at the over voltage protection. When there is no star like that, just turn it to the right, Now this is over voltage protection. Over voltage protection is a feature that if you set the output voltage above certain value, it will protect it. Let's say you're working with a 48 volts battery and you do not want to make mistake to set the output above 48 volts. You can set that, first turn it on and then press set, and let's go here and set it to 48. Now press this button so that disappears and everything is there. Just press set, then press MET, so this shows that it is saved, and then rotate to the left and exit. Now output is 70 volts. If I try to turn on the output, it goes off. You see, it just went on. It just went on and off because the output is set above 48 volts. But if I set it to, let's say 47, 46 volts, and if I turn this, it stays and the output is working now. Now let me show you over current protection. When the star is not here, press set, it disappears. Rotate this until you see OCP, over current protection, and it is off. Turn it on. Come here by pressing set with the arrow, come to the left. Let's say you want to never go above 10 ampere. So when this is done, press this button to exit, press MER to save it, and then just when there is no underline, just rotate to the left until you exit. Now over current protection will not allow any current above 10. Let's set the current to 11 amp and then turn the output on. And if I have a load that draws more than current, it will turn it off. Let's have a look at the auto turning on. That's an excellent feature when you turn on the device when the power comes. For whatever reason, you're connecting it to solar, to the battery or whatever, and if the power arrives at the input, you can automatically control the output to be turned on or turned off. So that's called ATO. When there is no star, press rotate to the right and until you see ATO. So this is automatic turn on or whatever you call it. So this is ATO, automatic output. Press this and it will be on. Now let's rotate and exit. Now output is off. As you can see, output is 46 volts. I'm disconnecting it from power. Now there is no power. It should turn on automatically. No, output is not on. Let's see. It says it's off. So let's press it. It is on. And then after that, press MER. STD. Now it's saved. Now turn left until you exit. Now let me disconnect it. The output was off. If I connect it again, you see it went and output is on. As you can see, it's ready. Let's turn it off. I don't want that. Now press this to turn it off, and don't forget MER to save it. Saved, and then go back. And now if I disconnect it and if I connect it again, the output is off. Now let's have a look at the MPPT mode, where it can control the output. It can control input and output. And here are my connections. I've connected the power supply with the maximum 65 volts here at the input, and output is connected to my electronic load. I've also connected two sensing cables so the voltage does not drop or if it's dropped, we just read the correct value. Let's start checking the voltage. Now let's check the input and output voltage. As you can see, the input is around 10.4 volts, and I've set the output to 35. Currently it's in 1 ampere test. I've set it, so let me change it and see the maximum voltage that we can get. So I'm pressing the set, and now I'm rotating it. As I rotate, you can read the voltage in here. Okay, so now you will see the input voltage in here, and the output will be on this screen, and this is the current. I've set it to 1 ampere, so we can continue checking just the voltages. The input voltage is 10.7 and output is 45. At the moment, I'm just gonna see at what voltage it will stop. So let me reduce the voltage. So as you can see, at 10.4, it was just changed to 9.8 volts. So 10 doesn't work, actually. It's supposed to be 45 volts. So 10.7. Now keep in mind, so it's around 11 volt, the minimum. Now let's go with the maximum, with a 10. Let's see what we can get. Pay attention in here. So that's 120 volt, and output has not changed, even though I changed it. 120. So the last value that was running is saved, not 120. And this one is saying that continue and set the voltage. And as you can see, 120 is not outputted even though I've set it. Now I'm going to increase the input voltage and see what happens. So when I went to 15, the output is 110 volts. I can hear some noise. So at 22 volts, I'm getting 120 volts, but not at all voltages I'm getting 120. This is 1 ampere. Imagine if I change the current. Let me change it. So I'm going to change the current later. This is just for voltage test. The voltage reading is now very accurate. As you can see, 120 volts, that's only 200 millivolts difference. And we are reading so now if I reduce this voltage, we will not get 120 volts. So if I go below 18, pay attention. At 17 the voltages, as you can see, at 15 it changed 110 volts, so it's not stable. In order to get 120 volts you need at least 17 volts. So with 17 you can get 120 volts, and this is only 1 ampere. I have not checked it. This is just general open circuit voltage. Assume it as open circuit voltage. Let's turn this off without load, and now let's see without even a single ampere. As you can see now it's at 14 volts, it shows 120, which is not true. So we have to have 1 ampere, and let me turn this on. So you can see that. So at 18 volts we are getting 120 volts. Now with 18 volts, let's see what we can get the minimum voltage, the closest to this. We can hear some noise. So from 18.7 we can get 19, so that's very close, almost less than a volt, the difference between input and output, which we are going to test it later. Now I'm going to increase it to 65 volts. So now input is 65, as you can see the output changed to 64, which is not correct. It must be higher. Now 66 is working, so we are getting 66. The current is 1 ampere, but it shows 890 milliampere, which is not correct. This is a lab equipment, very accurate. So 1 volt difference, with 1 volt difference it can output the voltages for you, because it's boosting it always. So that's very nice. While the output is connected, you can also change the voltage. The current shows at 120, it shows 900, and we can see it here. Now let's start our test. Input voltages. Now input voltage is 65 volts, and we are going to test it with 70 volts. We're going to test it 120, and we will come down. Let's go with 8 ampere. That's 960 watts. And fuse blown. I don't know what was blown. Yeah, the fuse was blown. Here it just turned black. I should have calculated it, but I just went without calculation, didn't pay attention. This was the fuse that was blown up. Now I have another one, you see, connected. So let's put it. And as you can see, this is already burned. Something is wrong. So the module is died because this fuse is not working. Yeah. This is dead. What is going on? So I could not do the test. This just died, and it was my fault. But the thing is, why? So the fuse should have just prevented the overcurrent, but now why there is a short circuit now? You see? Wow. So I'm setting the voltage to 120 volts. That's the maximum. And let's change. Oh, output is on, off. So now the current we can set is maximum 12. So I've set this to 12. And now output is on, the current is 0. Now as you can see, the output voltage is 120 volts. Let's turn on with 100 ampere. Now it's on. Now this shows the input. The input voltage is now so let's start now with 120 volts output, and we are going to test it with different power. And input voltage is now, let me show you, input voltage is 39.4. Let's go to 65 volts. As you can see, we have now 65 volts at the input, and we are getting 100 watt, and it is on. Let's turn it on. The current is 0.7 or 0.8 here it shows, and that's the discrepancy. See, now this device is correct and this is not correct. So this is actual lab equipment, and input current is 1.64. Let's go 200 watts, and now at 200 watts output is 1.66. Input current is 3.22. And I have to show you also the current here. Maybe this way is better, 3.16. And let me stop the ripple. The ripple is 524 millivolts at 200 watts. Let's go 400 watts. So now the output is 400 watts. The current is 3.32 at 120 volts. Input current is 6.43. And here is the efficiency. Let's go 500 watts. Now, as you can see, output is 500 watts. The current is 4.15 ampere. Input current is 8.14 ampere. Let's have a look at the ripple. 516 millivolts. That's the ripple. Let's go 600. Now output is 600 watts with 4.98, that's 5 ampere. Input current is, however, 9.84 ampere. And here is the efficiency. يا خدا جاني شو خدا يا خدا I believe this just died when I turned it on. This is the second module on which I paid a lot of money. Now my test is stopped. I will not buy another module because this will be too costly. So the fuse is good, but now I have power here. Let me show you. So here's input voltage 64.9, 65 volts. We have 65 volts at the input. So maybe my microcontroller died because this never turns off. It means that my microcontroller has died, or the power regulator that supplies. I am not going to spend time on this. Let's reduce input voltage to 42 volts now, about 40 to 50 something, 46 volts. Output is disconnected. Now this shows the output as a voltage. Nothing happens. So, now conclusion is that I didn't go above 10 ampere with this one, or in terms of power I didn't go above 600 watts at the output. Input was 65 volts, which was very high input voltage, but the device has simply died. Now I purchased this long ago, which they give you 15 days to contact the seller. Now AliExpress will not do anything and the seller will not do anything. So I will send them the picture, I will send them the video as well. If died, if they replace it, I'm going to do the test, otherwise I will give up, and that's the test price. Because now I've already paid over $100 for the two pieces. I can't do it anymore. So be careful. If it worked for you so far, maybe you're lucky, but this cannot be trusted. It can die without any reason, because I've operated it within the instruction, within the limit of voltage, power and current, and this cannot be trusted. Let's see. I'm going to open it and see if I see something smoking or not under the display. Let's remove this. So that's a connector for the LCD. Visually, I don't see any smoking part or burnt item. Maybe I'm missing it, but I can't see it. So maybe it's the fuse again. Let's remove the fuse. I've already checked the fuse before, but let's do it. Yeah. So the fuse is good. The first module also died because the fuse did not work. It later on blew up. You can see the smoke here, but it did not protect it when I went to 900 watts. Now for last resort, this is the voltage regulator that receives the voltage and converts it. But this one shows no output. I just checked it. And this is the chip, XL Semi XL7015, and pin 2 is the switch, and it doesn't have any output. The input receives 46 volts. And I just connected it. Input here 46, but this is the first pin, which is 40. This is reflecting too much. Okay. So you can read it. That pin. And the second pin is the switch pin, which is supposed to output, and it is 0. Now this could be, this is the actual device that seems to be dead, because if we look at the diagram here, pin 2 is just outputting normal voltage. It doesn't do any much. But this switch and this diode is taking care of the voltage. So one reason could be that this external diode is dead, or because it shows 0, short-circuited, or the switch is dead. So the easiest. Now if you look at the circuit diagram here for this, the pin 2 is just a switch. So the same voltage will come here, but it will be just turned on and off. So we should see the voltage here. There could be 2 reasons. One, internal protection is protecting it because this diode is dead, it's short circuit, and that causes this to show 0 volt, or this diode is good, the device itself is dead. Now I have disconnected the power. The capacitor still shows some voltage, but if I check it, input voltage still shows pin 2, it shows 0. So I have to make sure that these capacitors have no charges. Let's just short circuit them. Okay, so they're done now. No charges. That's good for the output as well. Yes. So now let's put this in diode test. And I believe this is the diode that is connected because this pin seems to be there. Okay, so that was open from the other side. So 0.6 volts, but it just turns on and off. Okay, that's good. And the other diode, that is showing short circuit, but we should not come to conclusion because it's inside the circuit. To make sure that that works fine, let's test the other piece the same way. So 0.5 volts when the circuit is not connected. But this one, so this is now, it seems short circuit. So the first thing, I'm going to remove this capacitor diode and put it there. Let's go to continuity. Let's go to continuity, and if you look at the diagram, the diode should be connected to pin 3 from this side and pin 2. The anode should be to pin 3. Let's check it with continuity. Anode is this side and it should be to pin 3. Yes. So this is our diode and the cathode to pin 2. Now, let's check the good one, the one that is dead differently. Anode to pin 3 and then cathode to pin 2. Good, but I've removed the diode, and these are the diodes that I removed, and let's check them with the diode test. So cathode is on this side, let's check it. 0.5 volts, and the other one. So I was wrong, the diodes are good, but that is helping us to see. Now I'm going to compare it with the other module. Let's check this continuity tester. Pin with the main device. So this pin is pin 3. And then the inductor is connected also to the output, which is going to this module, to this chip. So cathode should go to pin to this 5 volts. Yes. I've labeled them as 1 and 2. 1 is the first one, which was the first one that died It has short circuit at the input, but this one is 2, which we are going to try to repair. So I'm going to replace this converter, the XL7015, with this one. So okay, so I remove this capacitor in order to remove the chip from here. First I removed the diode, and the diode was okay. So I suspected that this regulator was bad, so I removed this capacitor, and here I put this back and replaced it with this, but I broke one of the pin. This is the last pin, pin 5, and pin 5 is enable pin. Hopefully this is not used, so let's see. So enable pin is to load the output on the device to turn it off. So this will power off the microcontroller or the output. Let's see if this has been used or not. Okay, so here, let's see. So it seems that pin has not been used here because this line is going like that. But let's have a look at this one to see if we can see it. Okay, let's just connect this. I'm not going to connect the wires. So let's connect it to power. Either it smokes or we see some power. So that was the reason. So the switch has died and we fixed it. Alhamdulillah. All praise be to God. Now let's connect and start our tests. Hopefully this doesn't die this time. Powered up. The output is off, so we can see that fluctuation. But let's put it as 100 watts on. Everything is okay, let's turn it on. The current is now 0. The voltage is 4 volt and not working. Turn off. So the current and voltage. Now let's go higher. I'm going 48 volts. No output. So I thought it was a matter of power, but it seems something else is also not okay. Let's see. What is going on? Oh, this is frozen. No worries. Off. Let's control delete alt. Task manager. And now let's start our test. I'm going to reduce the screen size so we can see the module better, and I'm going to connect my current sensor, my current meter, so we can see the current here as well. I'll try to show both at the same time now. And like this, it will be better. let's see. Now we don't see the input voltage, so if I turn it off, you see here that is 48 volts. Input is 48 volts. Let's go, because before I went with the 60 volts and the device died, so I'm going to do the test first with the lower voltage, then I'm going to increase it if it dies at the end, so at least we have some tests. Let's go 50. So 100 watts. Turned it on. Does not work. Why? 100 watts. 200 watts. Oh. Now, let's start with 100 watt and output on. This is now 100 watt and here it shows 90 watt. Input current is now 2 ampere. Input voltage 50 volts, input current. Output is 1 ampere, 100 watts, 100 volts. So this is exactly the Ohm's law and power. So it works. Now here is the ripple, 446 millivolts. This is the ripple. And let's go 200 watts. Now we are 200 watts and this shows incorrect. 193 watts. Input current is 4 ampere. And 570 millivolts is the ripple. Here is the efficiency. Now let's go 300 watts. Now we are getting closer. This 300 watt is showing a little closer. So 300 watts, 3 ampere. Input current is 6.2 ampere. Here is the wire turned off. It shows off, but output is on. So here is the ripple, 516 millivolts. Turned off. I'm going 400 watts, 400 watts, 4 ampere, because it's 100 volts, input current is 8.45. Here is the efficiency. There is the ripple now, 872 millivolts. I'm going 500 watts. Now it's 500 watts. Input current is 10.7 ampere. So we are not allowed to go higher. I have to go back. Now we are not allowed to go above 10 ampere at the input. So I stopped it, and we are going to test it later. Even if there's drive, I'm going to do the test, don't worry. But that was the maximum. If I go 500, so that is 10 ampere. I just jumped even above 12. So 10 is the maximum that they said let's not go. Now I set the input voltage to 40 volts. Let's do all the tests and make sure that we don't go above 10 ampere. And now I set the input voltage to 40 volts. And let's start with 100 ampere. Make sure to pay attention that this doesn't go above 10 ampere. At 100 watts, 1 ampere, 100 watts output is 100 volts. So 40 volts, 100 the output. Here is the efficiency. Let me show you the ripple. 560 millivolts is the ripple. Let's go 200 watts. Now 200 watts, 2 ampere input. And input current is 5.3 ampere. Here is the efficiency. And here is the ripple, 680 millivolts. 300 now, 3 ampere, 300 watts. Input current is 8 ampere. Here is the efficiency. And here is the ripple, 1 volt. $904. Now if I go 400 watts, it's 10.8. So that's the thing that I do is now it's not because in the manual they say go with the 10 ampere, but maximum is 12. So with 4 ampere, input current is 10.9 ampere. Here is the efficiency. And here is the ripple, 1.27. So that was the maximum because input was going above 10. Now I set input to 30 volts, and here at 100 watts, again with the output of 100 volts, input current input is 3.6, 3.59 ampere. Here is the efficiency. The ripple is 495.96 millivolts. Let's go 200 watts. And input current is 7.12 ampere. And here is the efficiency. The ripple is 728 millivolts. Let's go 300 watts. Now we went above 10 ampere, which I did not want to go. Now I set input to 20 volts. This is 100 ampere, 100 watts at 100 volts output. Input current is 5.2 or 5.3 ampere. Here is the efficiency. Here is the ripple, 576 millivolts. Let's go 200 watts. 200 watts. The voltage has been reduced to 88.8, even though we set it to 100 volts, so not acceptable. It did not produce. Let's go. Even at 100 watt, it's just giving me 94 volts, not right. Let's turn it off. You see, it is set to 100. Fan is running. Even now input current is 5. Why is 5? Something is wrong. Now this is wasting energy. No. Now the output is off. It is set to 100 volts. Let's turn it on. So we can see 100 volts, but if I go 100 watts and turn it on, so it's 94. Not producing 100 volts, so that's a failure. At 20 volts you cannot get. So, and this was, it was so much heated up that the solder was moving. I hope it was recorded, I'm not sure. But do not buy it, because this is now turning on automatically, even the output is not connected. Let me show you again. So, now the current is 0. Let's show you. 11 ampere. Now I turned off the load. The load is off, but this shows the voltage here. And it's on. It's not turning off. Let me show you. It's set to voltage. 12 voltage. It's outputting the same as the input is and the output. So this is now dead. 12 volts, and 12 volts just goes if I turn it on. However, it outputs about 80 volts, 86 volts, 87 volts. So that's it, guys. I could not spend more time on this because this has already failed. And as you saw, when I was testing it, just died without any overload, without anything that I did wrong. But the first one was my fault, which I went about 900 watts. So do not buy it, do not invest unless you have no choice. And if you're taking the risk, this is very risky. It might kill your output product, it might change the output voltage. You see, now it's off, but I'm getting $50 volts at the output, even though it is off. So 12 volts. But let's increase it. Now I increase the voltage to 22, 30 volts. Again, still it shows 30 volts at the output, even though off. If I turn it on, it shows 100 volts. and that is very strange. If I go 100 watt and turn it on, it is producing 100 watts. 3 ampere. So now as you can see, the output is off, but we are getting 30 volts at the output. And if I turn on the load, 100 watt, so 100 watt is being delivered, but the voltage is 27 volts, this is 29, so the input is just passing through. And here is the input current, 3.52, let's turn it off. But if I turn it on, however, 100 watt, 100 volts, the voltage works, the output works. With 100 watt, 30 volts input, 100 volts output. Now, even though it's not working properly, but I'm just testing it, 30 volts input, output is 80. And let's turn it on. You see it was off, so now it's on. Let's go with 100 watt, 80 volts, 100 watts, delivering. This shows now 105 watts, that's incorrect. Input current is now 3.57. Let's go 200 watts. Input current is 7.35. Voltage is still maybe acceptable. I have voltage sensing cable connected, so there is no drop. So there is no voltage drop in the line. 300, so 11 ampere, not good, because this is above the recommended value, even though they say 12 amp. So 300 watt is 11 ampere, 11.27. Let's go 70. Now output is 70 volts, but we are reading 68. So 7 ampere at 200 watts, at 100 watts 3.6, 1.14, and output current. This is getting very hot, the switch. The piece that is at the back here, this diode, not switch, sorry, the diode. Let's set it to 100 watts, 60 volts. Input current is 3.56 or 3.6 ampere. This is also 1.1 volt drop. Let's go 200 watts, 7.3 ampere is at the input, output is 200 watts. If I go 300, it will be 11. Too much load. I'm not going to risk it. So, this is all with 30 volts. Let's set to 50. Now output is 50 volts. As you can see, we are reading 48 point something. Let's make it 50, and here, so if you put it at 52, you will read around 50. So at 200 watts, 7.4, 7.38 amperes at the input. If I go 100 watts, 3.57 is the input. Let's set it to 40. Now 30 volts input, 40 output, 100 watts, input current is 3.6, 200 watts, 7.38, the voltage is not 40, as you can see. So 2 volts discrepancy shown here. Now I cannot go, let's see. Thirty-six volts. 36 shows now 34. So you can get 35 volts from 30 volts input. I'm not going to go below that, it might damage it. So input current is 7.4. Now I set input to 18 volts, output to 120 volts. Let's go 100 watts. Turn this on. It's on. So we are not getting 100 volts as before that we saw. Let's go 100. 120 was not getting. So we're not getting 100 volts even. 90 we are not getting. $80 volts we are, it seems, no. $80 volts we are getting, but not sure. So this is 80 volts. Let's reset this. So it doesn't go above this value, 78, even though I set it. So if I reduce it, what happens? Okay, so it works with lower value. So we can get 70 volts from 18 volts. Let's increase it a little, yeah. 100 watts. Input current is 6.1 ampere, 200 watts, it's 12 ampere, it could not do it, I just turned it off. Let's set here 150, now I set it to 150, 70 volts, input current is 9 ampere, so we can get from 18 volts, 70 volts, output 150 watts, input is 9.47. And let's see if it can work with lower voltages. I'm going to reduce this. So as soon as I reduce it, output reduce. Not good.